Hello, everyone, and I hope you're happy with how the SMO Junior went. I did get to see some of you. I was just hanging around and I spoke to some of you after the junior paper. So I think mostly it was not terrible, right? There have been worse. I think a lot of you are generally okay with how it went. But of course, there is the danger that mostly okay with what you think, not what actually happened. So we'll go through the questions. We will look at some potential areas in which, if you are not careful, you may go wrong, as well as some ways in which you can reduce the number of cases that you're handling because there are just so many. Now, before anything, some of you are going to ask about cutoffs again, right? And so when it comes to cutoffs, let me just explain that for gold, it is based on round one and round two in total. Whereas for, let's say, the junior team, it is based on round two only. And for the top 30 and rankings, it is also based on round one and round two. So obviously, whenever we're talking about, let's say, gold and top 30, how many questions do I need in round two? I can't really say it that way. I can say that I think that for the junior team, most likely 3 questions is going to roughly be a cutoff. Now, 3 questions means 3 questions done properly, or maybe if let's say it's 3 questions with one tiny error, maybe, or maybe 3 questions with like an answer mark and partial progress on the other one. That's around my estimate. But obviously, it also depends on how many people they want to admit into the junior team. And everyone that was already in, let's say, the senior team, national team, does not count to the cutoff for the junior team because they will not get admitted back into the junior team again. Now, as for gold and top 30, as I'm going to mention in a while, it really depends on like how are they grading this? How strictly are they? Having said that, of course, if you think you solved everything, no matter how badly it goes, unless you are totally wrong, I mean, you have done well, congratulations. If you've done 4 questions properly, you have definitely done well and you should be safely getting a top 30. If you've done 3 questions, I would say it's around there, right? 3 questions should be enough for a gold most of the time, unless your 3 questions has a lot of issues and your round one was just borderline. But I'm not going to put a number there because, as we're going to see with the questions, it really depends on how much detail they want. And so this is what we should do for junior. Say as much as we can, even if it feels obvious, because the solutions are not that long anyway. Okay, so now we'll start looking at the questions. The first one is, in my opinion, not the easiest one. But I mean, it's quite a normal geometry. It's just that it's not like the easiest question. Unless you are very comfortable with geometry, and then you will say that this is very straightforward. A, B, C, D, A, X, Y, Z are rhombuses. They are external to each other, meaning they don't intersect. They have a common vertex A, we knew that already, and the vertices are labeled clockwise. I don't know where these two are relative to each other, but I can just draw one rhombus first. Now, remember that I did say in the mock paper just previously, use a bit of color to help you. And so I think I will use the same color for the first rhombus and I'll use another color for the second rhombus. But hang on, I have DAX equals to BAZ. So that means that if let's say I have this, remember it is going clockwise, then I need to make sure that the Z on the other side is also the same. So that will be what happens, and then I think you can quite safely just complete the rest of the rhombus. So this is your figure. We are supposed to show that the centers of the rhombi, this and this, and the midpoint of BZ forms an isosceles triangle. Now, the moment you draw it, you should be able to tell what the isosceles triangle seemingly is, which is these seem to be equal. And you will also see that this seems to go through A, I mean, when you draw it in any reasonable way. Even if you have no protractor, you can tell that the whole thing is going to be quite symmetric as well. I think we cannot just say clearly everything is symmetric because, they are giving you a symmetric looking figure. Your job is just to make sure that you do the symmetry right. You also need to justify the symmetry carefully, but otherwise this is not very hard to intuitively believe. Now, I think that when I saw this question, my thought was, let's just make it symmetric since it already is, and let's sort of have another rhombus. I mean, I think this will be another rhombus. Most likely it will be a rhombus. And then I asked myself, actually, do I know that it's a rhombus straight away? The answer is no. I do not immediately know that it is a rhombus. I know it should be a rhombus because it should be symmetric. But what I have is a pretty nice configuration. Okay, I think I should have moved my center a little bit because we know the center is at the midpoint of the diagonal. So we know that this is the midpoint of the diagonals, and so therefore we do know that if, let's say that I call this points PQRS, your Varignon's theorem tells you that PQRS is a parallelogram. Varignon's theorem, for those of you in my class, I mentioned it. For those of you who are not in my class, the last time it was used in a question is, I think, in 2008, where it was explicitly mentioned. But basically, Varignon's theorem is just your midpoint theorem, right? RS is parallel to DZ because of the midpoint theorem, also parallel to QP, and then likewise for RQ parallel to BX parallel to SP by your midpoint theorem. So if you didn't have Varignon's theorem, I mean, this is still a simple explanation. Now I like this because this gets me almost there already. And then I just want to say that it is by symmetry going to be a rhombus. But again, it's an easy question in terms of the amount of symmetry. There is so much, so we cannot just say the whole thing is obvious. So be very careful. I know that right now the opposite sides are equal. And I essentially just want permission to flip it over because it so obviously looks like it can be flipped over. So I'm going to do that by just claiming that the triangles BRS and RDQ are congruent. And of course, you would say, well, is that obvious? That is almost obvious. It is almost obvious because I don't know that these two are the same. I know they should be, so I can just name the congruent triangles first to get that. So BAZ is congruent to DAX. That's where the angle that they give comes in. So BR equals to, so BA equals to AD. ZA equals to AX. Those are just from the rhombus. And BAZ equals to DAX. So I know this. Otherwise, then this would confirm to me that BZ equals to DX, and so BS equals to DQ, and so that means that I can say that BRS is also congruent to DRQ by SAS. Now, I think that you do not need to worry if you did not specify everything explicitly in terms of the reason for your congruent triangles. But you cannot just say obviously they're all congruent. So if let's say you said by SAS, but you didn't mention what they are for DAZ and DAX, I think it's understood. This is also not the only way because there are so many symmetric things. So there are lots of other congruent triangles that you could have stated. So this too is that SBR equals to QDR, and therefore this is actually a rhombus. Which of course means that the triangle RSP is isosceles. Okay, so I think for geometry questions in terms of grading, they're not going to be too fussy as long as you have found a sequential approach of doing it, and there are certainly many. So I would not worry too much about the grading of the geometry unless you just jump straight to clearly this is equal to that without any further explanation. Okay. All right, question 2. Find all 6-digit integers n such that n is a perfect square and that the number formed by the last 3 digits of n is one more than the number formed by the first 3 digits of n. I think this is pretty similar to the question 2 from 2022 or question 1 for 2022. It was also blocks of 3 digits and 3 digits. And so therefore, if you have tried that question and you apply the same idea here, the starting point is also okay. Right? You can let the first 3 digits form the 3-digit number x. And then, so that means that your n is the number basically x and x plus 1, which is 1000 x plus x plus 1, which is 1001 x plus 1. Okay, so this is the interpretation of that. We also have the n is a perfect square. So if I just let n equals to m squared, then basically the task is from a modular arithmetic perspective, since x can be anything that is small enough to fit, which is a 3-digit number, m squared is supposed to be just 1 mod 1001. However, I guess from a SMO junior perspective, another way that you can just see that is the very classic difference of squares that shows up a lot. Right? We have the ability to factorize 1001 as well as m squared minus 1. And so therefore, what you need is that m plus 1 and m minus 1, one of them must be divisible by 7, one of them must be divisible by 11, one of them must be divisible by 13, but it can be any mixture of them. So for p equals to 7, 11, and 13, either p divides m plus 1 or p divides m minus 1, i.e. m is congruent to 1 mod p or negative 1 mod p. Now, here comes all the bunch of cases. Basically, you just need to sort of have a table of m mod 7, m mod 11, m mod 13. And this would give you, by the Chinese remainder theorem, you don't have to cite the Chinese remainder theorem, I believe. For junior, it should be okay to just say that it would give you m, or m mod 1001, or just the number m is still fine. And the thing is that we cannot be sure that any of these are technically discardable. So we do have to write all of them. And this will happen for a lot of today's round 2 paper. You can't really discard cases too casually because A, you may actually discard a case that works. And B, if you just say that by checking cases we are done, there is actually nothing to do for most of these questions because many of these questions are just checking cases. Is that the sign of a good variety of questions? Debatable, but certainly it means that we cannot be too casual. Okay. Now, at the same time, you don't really need to show your working. You can just say that, for example, if you want to say by the Chinese remainder theorem, or even if you just mention as a statement, or even if you don't mention, I think it's fine. But I would just say to be safe that M mod 7, 11, and 13 gives a unique M mod 1001. Okay, so for 111, you know it's just going to be 1 minus 1 minus 1 minus 1 is just minus 1. For let's say this with two ones, it means that you will combine those two to be 1 mod 77. And then after that, you will basically just keep on adding 77 until it is negative 1 mod 13. So like it will go to 78, which is 0 mod 13. And so you add another one, it will be 155, which will be negative 1 mod 13. So let's say this would be 155. The small shortcut you can have is that you can conclude therefore that this would be negative 155 straight away without having to calculate all of it from scratch. So you can sort of halve your effort by the fact that it is symmetric. Okay, so we still need to do two more. This is inevitable, and I would say you do not need to show your working for this kind of calculation. So when you're doing round 2, you need to explain what is your process of considering. You do not need to explain to me the process of how you calculated. Like calculations, we understand. But if you showed it, it's okay. Right? So if you showed it, it is fine. And if you didn't show it, it's fine. But you do need to show me the cases. You cannot just tell me at the end M is this, this, or that. I think that is like, how did you find that? It's not very convincing. Okay, so this one, let's say here and here, 1 mod 143, 143, 1 mod 91, sorry, 143 is the other one. 1 mod 91, and then 91 is itself 3 mod 11. So if you go 4, 7, 10, that will basically be adding 91 3 times, you get 274. This one here, therefore, would be negative 274. And then after that, the last one here, which is minus 1 mod 11 13 is minus 1 mod 143. 143 is 3 mod 7. So each time you add 143, it will go to 2, then to 5, then to 1 mod 7. So 3 times of 143 is 429. This would be 428. Okay. Coincidentally, this happened to be ascending order. That is a coincidence. So you know that the M you can just substitute in to find your X, or if you want to, you can just square a few 2-digit numbers to check. However, we do know that your M squared is supposed to be a 6-digit number, and so these are too small. This one doesn't work either. And so otherwise, at some point, you do need to either calculate X or calculate your N just by squaring. Now, I would suggest squaring. You have time in round 2. This is the best way to check your answer, right? So do the squaring because then you know that your logic and your calculations are fine. So the 428 would give you 183184. The 573 would give you 328329. I'm just fast forwarding this. You do not need to show them long multiplication either, because that is not part of a proof in a way. The proof is just how do you know that you have covered everything? And I somehow have just forgotten to write 727 squared down, so let me write that down too. Okay, so this is the list of 4 values. Now, I believe that if somehow you, let's say, missed out one of these cases, but otherwise your logic is fine, I think that's probably like a 2-mark penalty, I would guess. If somehow you missed out 2 of these, maybe it would be like kept at a 5 out of 10. But I'm not sure, because the marking scheme is up to the graders. Okay, so that's for number 2. Now, number 3, cases again. Right? Because Jack chose 3 dice, Jill can select some of them, possibly none, turn each of them to the opposite side. Jill wins if the sum of the values of the dice is a multiple of 4, which means after flipping. Can Jill always win? And then note that the game is played with dice where the sum of the numbers on opposite sides is 7. Now, if this is the case, it means that Jill essentially has 2 choices. The side that was originally faced up, or the reverse, which means 1 and 6, 2 and 5, 3 and 4 are the 3 types of opposites on a normal die. I want to reduce this down because I realize that the whole thing is mod 4, and therefore both of these are just 1 and 2. Mod 4. And therefore Jill effectively just has the choices of 1 or 2 in both of these cases, and then 3 or 4 in the third case. So that will reduce the number of cases so that we don't have to list so much. Now, I'm going to just sort of say that this is my to be concluded, right? So will Jill win or not win? I can just write first, right? Because the rest of it is going to be just checking the cases and looking for a case where Jill doesn't win, or just checking that all of them Jill will win. So we can just say that the thing I said, just write it down. Note that the numbers can be considered mod 4. So which means that the Jill's choice for each die will either be 1 or 2 or 0 or 3 mod 4. I'm going to let these 2 dice, I will call the dice, let's say, I'll just call them 1/2 and 0/3 dice respectively. Don't need to give them a fancy name. And then again, another table. And Jill's selection. Okay. So if there's any that doesn't work, then I can also check all the cases. But as you may infer from the fact that I'm drawing a table and not just mentioning one of them, yeah, indeed they all work. Right, so if it's 3 of these, then just 1 plus 1 plus 2 is 0, mod 4. If it is 2 and 1, then it is 2 plus 2 plus 0. If it is 1 and 2, then you can use 2 plus 3 plus 3. And then if they're all this, then just 0, 0, 0. So which means that Jill will always win because of the fact that there is always a selection. Okay. So you do not need to fill a table, but as long as these are the cases you considered, you'll be fine. Again, if let's say that you considered the cases by 1 or 6, 2 or 5, 3 or 4, and you didn't notice this, you would need to make sure that you cover every combination of 300, 210, and 111. That would be a total of 10 cases. If you covered those 10 cases, it is fine. But if let's say you did that and you only covered, let's say, 6 cases out of 10, I would expect there might be some penalty. How much penalty, I'm not sure. Okay, question 4. Now, based on what I've heard so far, which is not much, I have heard that many of you found question 4 to be a bit more difficult, which I think is a product of just the question being phrased in a weird way. It's really not that difficult. If this were asked as a round 1 question, I think most of you can solve it. Now, first of all, I will draw a 4x4 grid. I can't really avoid doing that 4x4 grid. So this is the center of the grid. Now, of course, A is arbitrary, right? It doesn't matter what the label is because A is there. So I can just call the squares A, B, C, D. I'll just label it clockwise. You can label it A, B, C, D or A, B, C, D. Whatever you want is fine. That is not asking you how many ways are there to label the squares, right? A, B, C are just the name of the 4 squares. Okay, so start from A, the frog. The frog wants to exit from A. And so we can look for just the pattern, right? If n equals to 1, that means there's 2 choices, right? You just exit straight away. The exit square is the place where you jump out of the center. Oh, okay. So if n equals to 2, it means that you move away, then of course you can't jump out, so there'll be 0. Right? You move away, then how do you exit from A? Now, if let's say n is 3, that means you have 2 jumps. You jump, and then you come back, and then after you go out. So you can go and come back in 2 ways, and then after that you have 2 ways to get out. So that's 4. Now, if n equals to 4, means that can you get back to A in 3 steps? And then how many ways are there to do that? I think it's quite easy to see that you can't get back to A in 3 steps, right? Because if you come here, then you can't go this, right? Because shares aside, you can't jump diagonally. So it means that it's 0, and I think I understand the first aspect of this, which is that, yeah, it is going to be always impossible for even because effectively you are just alternating between B and D and A and C. It's like A or C, and then you jump to B or D, and then you come back. If you start from A, then of course it means that on the odd numbered jumps, you will be at B or D, and the even numbered jumps, you'll be at A or C. So I can say this. Right, so label A, B, C, D as shown. Now, yeah, so if the frog has not exited the square, the center, after an odd number of moves or jumps, it is at B or D, and after an even number of jumps, it is at A or C. You don't really need to write any further proof of this. It's understood, right? It's just alternating. So I think you don't need to say further detail for this. So that means that for n even is impossible, since it will be at B or D after n minus 1 jumps. Now, meanwhile, after an odd number of jumps, I mean, it is possible to be at A. Now, not only is it possible to be at A, like, there is no real problem, right? Whether you're at B or D before that, you can still get to A. Which means that whatever you do previously kind of doesn't matter. No matter what you do previously, you will be able, on your last move, to just say, okay, I will go to A. I mean, on the last move before you exit. So, what I can say is that if n is odd, there are just two choices for each of the first n minus 2 jumps. And then after that, it will be at B or D. So it will just jump to A, right? So it jumps to A, and then there are two choices to jump out, as before. Right, and so very simply, it's just 2 to the power n minus 1. I think some of you got confused because of the even being impossible, but I would say that if the question had just asked how many ways are there for this to happen, let's say if this is in round 1 and it was just like n equals to 7, I think most of you would have solved it. So part of it was the round 2 kind of like psychological, I think this should be really hard when really, I think you understand exactly what's happening, right? It's not well, it's not as hard as the previous grid problem, which I said for I proposed for the 2023 one, right? That I think was harder because that had so-called 4 colors. This one only really had 2, just A and C and B and D. Okay, so I believe you will be a case where you get like just like 4 or 5 marks for the even being impossible, and then the other like 5 or 6 marks for the counting the odd. And of course it may be 4, 6, 3, 7, maybe 5, 5, but the noticing the odd and even pattern is the key to the question, and that will give you most of the marks even if you just like had an off by 1 error on your count. Now, if you thought that n jumps means that on the nth jump you jump out versus you thought that it is going to exit after n jumps, I mean, if you have an off by 1 and you explain clearly, most likely they will still give the mark. It means that if you're off by 1, it's because you read it a bit differently in a reasonable way. But I believe that this is the intended interpretation, right? The jumps includes the exit jump from the center to out of the center. I think that's the most natural way to understand the question. Okay, last one is question 5. And this is the one that is cross-listed with the senior. It was senior Q1. Now, I think that this is a question that looks intimidating, but if you really try it, it's not so bad. However, again, you do need to explain yourself because you cannot just, remember, you cannot say list out all the types of special quadrilaterals, right? You cannot say that, let me try a square, let me try a rectangle, let me try a rhombus, let me try a parallelogram, let me try a trapezium, and then let me try a kite. That's not how it works, right? I mean, there are lots of quadrilaterals which are just not special. So you cannot say, let me just try all the special quadrilaterals one by one. That is not, how the question works. So if you draw something, let's say not too special, I just draw something like this. This is the intersection of the diagonals, it's M. And then I just draw some random line through it, right? I think this is a random enough line. Now, needless to say, this is not going to look like the four of them are similar. I just drew a random looking thing. They don't look very similar to each other. I will think about whether these two are similar. The answer is maybe they are similar. I mean, this thing is equal to this. Okay, so if I want this to be equal to this, it means they are parallel. So if they are parallel, this will be similar to this. But if they are not parallel, is it possible to have some weird configuration where this is actually equal to that? Well, not looking like it here, but if let's say that we were to focus our attention on the other pair down here, which is here and here, again, these two are equal. In my not very accurate drawing, because I just drew a random example, it looks conceivable that this is equal to this and this is equal to this, right? It looks believably possible. Of course, the handful of you know that that's just saying it's a cyclic quadrilateral, but no cyclic quadrilaterals for junior needed. Anyway, some of you would have seen that this is conceivable, but the other one is kind of like an issue, right? Because if this is equal to this, is one thing, but obviously in here, it does not look like this can be equal to this because this is obtuse. Yeah, but then if we are thinking of obtuse triangles, then I think the bigger problem we have is actually just at the top. You don't have to look across it because I'm trying to find reasons why most quadrilaterals don't work. So rather than look for, let's say, these two being equal and try to make them similar, I think this doesn't usually happen at all. Right? This is quite a rare thing, and if you drew a lot of quadrilaterals, you know that too. Therefore, I'm actually trying to look for a simple reason why most of them don't work. This is how you approach a lot of these kinds of find all questions, right? I said this in the mock paper again. Find a reason as simple as possible to rule out most things. And so I'm just going to look at this obtuse angle here and say that is the culprit because this is obtuse and this is acute. And so based on that, I think I can already just make the argument that, yeah, this doesn't work unless it's a right angle because one will be obtuse, one will be acute, and we can just check it. Right, so I will just draw, let's say, the top half. Okay, so I think it must be a right angle. To split it up, probably split into half, I'm not sure yet. I will just claim that MP is perpendicular to AB, and if not, then without loss of generality, assume that the acute one and the obtuse one are like this, so MPB is the obtuse one. Now, the similar triangles, they are clever, right? They didn't name them, so we don't know what order it's in. But this must correspond to one of these three, and I think that they all fail for different reasons. So must be equal to one of triangle APM's angles for the triangles to be similar. But again, I don't think you can just say clearly it is impossible unless it's the right angle because otherwise the question has not much left to say. So I think you have to explain this actually line by line, otherwise there may be some penalty. How much? I don't know again. So APM is less than 90 degrees because it is 180 minus MPB. So that is the first one that doesn't work. The second one that doesn't work is PAM because that is just smaller, right? This is the exterior angle of that triangle. And in fact, both of them are just exterior I mean, this is the exterior angle that sums to the other two. So PAM plus PMA is equal to MPB, means that both of those are not equal to angle MPB. So this implies that this is rather anticlimactic. It is just going to be a right angle. The right angle must apply to both, which means it's just a trapezium. Therefore, AB and CD are just parallel, and I can sort of now investigate it once more for the case of a trapezium of yet to be determined character. This is supposed to be the line. Now, the fact that these are now similar to each other is just true because of the trapezium. It is guaranteed. I think you do not need to explain further. AB is parallel to CD is enough to justify this. This is our good old friend, that hourglass pattern. So we don't need to explain why. If you want to explain it using AA, SAS, I mean, it's 90 degrees. You can use anything. So these are similar, and we are only left to check whether those two are similar to each other. So we need triangle APM to be similar to triangle BPM, or now because this is the right angle, I know that the correspondence, there are two possible ways it can happen, right? This is perpendicular, could mean that it's just this case where they are congruent to each other. Right, so clearly they would be congruent. And if it is a line of symmetry, that means the whole thing is just an isosceles trapezium. That's the first case. Now the second case, if we were to just check it carefully, is the case where basically BPM and MPA, this is equal to this, which is nothing more than the nested right angle configuration that we are familiar with. So BMP would be equal to PAM. This is 90 degrees. And so therefore, if these two are similar with these two summing to 90 degrees, then it would also work. So it means that ABCD now is basically a trapezium. I mean, it's a trapezium kite, but which is with perpendicular diagonals. Now we can just say that checking both of them work because basically what we have said already is not just necessary, but it's also clearly sufficient. Okay, and so your conclusion is that AB parallel to CD and either BC equals to AD or AC is perpendicular to BD. Right, so I feel like this year's junior round 2 is the kind of paper that is really going to be in the hands of the graders. All of you can hope very hard that they're generous to you if you wrote a lot you would hope that they are strict. If you wrote little, you hope they're generous. It is very discretionary. So I think we cannot say what is exactly going to happen. I cannot even say how you give answer marks for some of these because there are so many answers this time, right? Like, let's say this one has 2 cases to mention. This one here, there is the even and odd case. This one, there are 4 different cases to check before 0 is the answer. This one, there's 4 cases. I am not sure how this is going to be allocated. I'm just going to show you that if your logic is correct and you just miss one case, a small case, it's going to at most be -1 or 2. But that is as far as I think I can guarantee for a set of problems like this. Okay, so feel free to leave any comments in the comment section below. I've also attached in the description typed out solutions which are sort of how I may potentially submit my solution. There's more than one way you can do it. So that's just one sample. It doesn't even look exactly like what I did in this video, but you can use that as a reference as well for, future purposes. Okay, so thanks everyone. If you are taking open as well next week, all the best. Otherwise, congrats making it to the end of the SMO season. Have a good rest and enjoy your weekend before school reopens.